So the first thing we're going to do is we're going to look at example number 1, and we're going to determine the exact values of the 6 trigonometric functions. We have 3 primary trig functions and then 3 secondary trig functions. And so I can see this is where my terminal angle lands. The terminal angle lands in quadrant number 4. We're always going to go directly back up to the x-axis, making a right triangle, always back to the x-axis, and then this interior angle closest to the origin is going to be the one that we are going to evaluate for the 6 trig functions. Now, this distance to get to this point, I'm going to move 2 to the right, so this is a distance of 2, and then I'm going to go down 4. We don't write -4, it's just +4 because we're talking about distances. Next, I need to figure out what is this missing length, and so I'm going to use the Pythagorean theorem. A squared plus b squared equals c squared. So 4 plus 16 equals c squared. I'm taking the square root, and yes, if you're wanting to be plus or minus, if we were only solving algebraic problems, it would be plus or minus. Because we're talking about a missing length, lengths will always only be positive. So this is going to be the square root of 20, but I do need to break it down. A perfect square that divides into 20 would be 4, and so this is the length 2 square roots of 5. 2 square roots of 5. I'm going to use this information now to identify the 6 trigonometric functions, and then I'll come back and I'll do the sign, knowing that this terminal angle lands in quadrant 4 last. Okay, what is the sign of this angle? Opposite over hypotenuse. I'm creating that ratio, opposite over hypotenuse. I'm going to reduce the 4 and the 2 to 1 over 2, so I have 1 over 2 square roots of 5. Mathematically, that's not wrong, but I know it's not in proper form, so I'm going to take the 5 and throw it on top. So it's 1 square roots of 5. Now on the bottom, I'm going to rewrite the 5 with no square root. When I simplify, I have 1 square roots of 5 over 10. And some students ask, is it necessary to put a 1 in front of the square root? It's not necessary. You can simply write square root of 5 over 10. If you're in the front half right now, other than tutors, you are writing all these notes down. So anybody in this region of the classroom is writing these notes down right now. What is the cosine? Cosine is adjacent over hypotenuse. So 2 over 2 square roots of 5. We're going to do the exact same thing. The 2's are going to reduce to 1 over 1, and I have 1 over 1 square roots of 5. Mathematically not wrong, but it's not in proper form. I didn't leave myself enough space, so I'm going to come over to this region. The 5 is going to jump up on top, so I have 1 times the square root of 5, and then on the bottom I'll have 1 times 5, which is 5. I'll come back and do the signs at the very end. Tangent. Tangent is the ratio of opposite over adjacent, so 4 over 2, which reduces to 2, or 2 over 1. Okay, to figure out the secondary trig functions, cosecant, secant, and cotangent, I'm simply going to take the reciprocal. So I'm going to go back to this form right here before I had to put it in proper form, and I'm going to take the reciprocal of this. I have 2 square roots of 5 over 1. I'm going to take the reciprocal of the cosine before I made it proper. I have 1 square roots of 5 over 1. And then when I take the reciprocal of 2 over 1, I get 1/2. In quadrant number 4, I have all-star trig class. Only the cosines are positive. So cosine is positive and it's reciprocal, cosine and secant. Everything else needs to have 1 negative placed into the trig function when we evaluate it. The second example is going to be very similar to number 1. It just looks a little more complicated because now we have a radical. So where do I find this point? That's my first question. Because it's a negative value, I'm going to go from the origin to the left, and then because I have a positive value, I'm going to rotate up. So choose a point in quadrant number 2, and then we're going to do the same thing. So my terminal angle lands in quadrant 2. I'm always going to draw a line back to the origin, and then from that point straight down to the x-axis. This is a distance of the square root of 2, and this is a distance of the square root of 7. We don't write a negative distance. That's why we don't incorporate this negative sign with the square root of 2 when we are actually measuring the lengths of 2 of the 3 sides of the triangle. How do I figure out this third side? I'm going to use the Pythagorean theorem. So I have a squared plus b squared equals c squared. Well, the square root and the square are going to, they look like they cancel out. Really, they simplify to 1. I'm left with 2. The same thing will happen over here. And now I have 2 plus 7 is 9. And I'm going to take the square root, knowing that we only have a positive because we are measuring length. This is a length of 3. If you prefer to identify the signs before you come up with the ratios for each of the trig functions, you can also do that. And this is what it would look like. In quadrant 2, all star, S stands for sign. So sign is positive and it's reciprocal. Everything else will have one negative sign. Okay, let's create those ratios. So this interior angle closest to the origin is what I'm evaluating. The sign is going to be opposite over hypotenuse. So square root of 7 over 3, and I'm going to do this right away. So this is 3 over the square root of 7. Again, mathematically not wrong, but it's not proper. So 3 square roots of 7 over 7. Cosine is going to be adjacent over the hypotenuse. Square root of 2 over 3. And when I take the reciprocal, it's going to be 3 over the square root of 2. Let's make it proper. So negative 3 square roots of 2 over 2. Can't be reduced. And finally, let's do the tangent. Tangent is going to be opposite over adjacent. Now this is a little bit trickier. Opposite over adjacent. So I like the ratio, but I don't want to have a square root in the denominator, or any radical, in fact, in the denominator. So I'm going to multiply by the square root of 2 on the top and bottom. And what does that look like? I would have the square root of 14 over the square root of 4. And I know the square root of 4 reduces to 2. The square root of 14 cannot be broken down any further. Let's now take this same position before I did any type of rewriting in equivalent form, and let's take the reciprocal. So we would have negative square root of 2 over the square root of 7. And then let's make it proper. Times the square root of 7 times the square root of 7. That'd be negative square root of 14 over the square root of 49. And I know the square root of 49 is equivalent to 7. So negative square root of 14 over 7. In the last two remaining examples, we are going to evaluate only the sine, the cosine, and the tangent. So the 3 primary trig functions, and we're not going to use a calculator. So we need to figure out how to do this. So here's what I know. I know that the sine of an angle is equivalent to 1 over, I wrote it down wrong, is equivalent to 1 over the cosecant. So I know that if the cosecant is negative 25 over 7, that tells me that the sine of an angle will be negative 7 over 25. I'm just taking the reciprocal. I keep the same sign. So I'm going to draw myself a triangle. And I'm going to ask myself, I'm going to draw myself a Cartesian plane, an XY axis. And I'm going to ask myself, where do I find sine values that are negative? Sine values are like y's. So in these 4 quadrants, where do I find y values that are negative? That'd be in quadrant 3 and in quadrant 4. So I'm already going to cross out quadrant 1 and 2. It's not an option. So this is where I could find this. But I have one more detail to add in. It says the cosines have to be less than 0. That's a fancy way for saying the cosines must be negative. Cosines are like x values. Where are cosines negative? Where are x values negative? That would be in quadrant 2 and in quadrant 3. So if the cosine has to be negative and the sine has to be negative, I know that I'm going to be in quadrant number 3. So please place a dot anywhere in quadrant 3, and then this is going to look much like example 1 and 2. I'm going to go directly back to the origin, and then this time straight up to the x-axis, creating that right angle. The interior angle closest to the origin is going to be the angle that I'm going to evaluate, and I'm only going to do it for sine, cosine, and tangent this time. So I'm off to the side. I'm going to evaluate the sine, the cosine, and the tangent. What do I know here? I know to get to this point, I had to go 7. Oh, sorry, I did not have to do that. I know that this angle has a sine of negative 7 over 25. Forget about the negative. That just helps us to determine which quadrant. So if this angle has a sine of 7 over 25, opposite of this angle will be 7, and the hypotenuse will be 25. Now, how did I know that? I knew that because sine is a ratio of opposite over hypotenuse. How do I find this missing length? That's the adjacent side. Okay, a squared plus b squared equals c squared. So 7 squared here, would be 49. 25 squared, can you guys quote 25 squared should be 625? I'm almost positive, but let's make sure that I'm right. 625. And now I'm going to subtract 49 from 625, and I end up with 576. I'm going to take the square root of 576, and I get 24. So A is equal to 24. Because it's a length, we're only going to worry about the positive, not positive and negative. So if it helps you, you can rewrite this triangle. 7, 24, and 25, and this is the angle that I'm evaluating. In quadrant number 4, all-star trig, T stands for tangent. Only the tangent is positive. Everything else is negative. So in this angle, sine is going to be negative 7 over 25. Cosine is 24 over 25. And tangent is opposite over adjacent. Here we go. So I know the sine is a positive value. Sine is like a y value. Where are sines positive? In quadrants 1 and 2. It also tells me that this angle that I'm going to create from a terminal angle will occur between pi over 2 and 3 pi over 2. So it's going to be in quadrants 2 or 3. So if it's in a quadrant 2 or 3, but it has to have a positive sine value, that means we're going to look right now at quadrant 2. So I'm going to make a Cartesian plane, an xy axis. I'm going to go anywhere in quadrant 2. I make a dot. It doesn't need to be specific where you're drawing that. Go back to the origin and straight down to the x-axis. This is our last example before you get busy. This is the angle always closest to the origin that I am going to evaluate. Now, what does sine mean? Sine means opposite over hypotenuse. Okay, opposite is 5, and 6 is going to be the hypotenuse. I need to figure out what is that missing length. In my mind, I already know it's not going to be a Pythagorean triplet, so I got to do the work. A squared plus B squared equals C squared. So A squared plus, well, 5 squared would be 25, and 6 squared would be 36. I'm going to subtract 25 to the opposite side, and I end up with the 11. I know the square root of 11 cannot be broken down. We are only going to evaluate sine, cosine, and tangent. Now, I'm purposely going to make a mistake here, and I want you to raise your hand when you see what my mistake is. 5 over 6, radical 11 over 6, and 5 over the square root of 11. Now, if this was my final answer, I see 3 mistakes that were made. Do you have a question, or you know what it is? Okay, I see 3 mistakes that were made. I have one person that sees a mistake.
Well, one of them is that for 10, you're not supposed to have a square root. It's not wrong, but it's not mathematically.
Sure, so let's rewrite this. 5 square roots of 11 over 11. Okay, so this is what I am going to now say are the correct answers, and I still have 2 remaining mistakes. Yep, Solana, what's another one? Yeah, something to do with science. Can you be specific?
The all-star.
Let me write this down, because if you're a visual learner like myself, all-star trig class, okay? But we are in.
Oh wait, no, only the sine.
Yep, we are in quadrant 2. S represents your sign. Only sign is positive. Okay, this is positive. These need to have a negative. Sometimes students say, like, where does a negative need to fall? It doesn't matter. It can be on top, on the bottom, in the middle, as long as there's only one negative.